Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The hydration of alkynes under Markovnikov conditions using H2SO4 and HgSO4, mercury, 2-sulfate, proceeds via an enol intermediate. The mercury catalyst facilitates anti-Markovnikov free Markovnikov addition of water across the triple bond, forming a vinyl alcohol, enol, as the intermediate, which then tautomerizes to a ketone. Moving on to the next step. When an internal or terminal alkyne is treated with H2SO4, HgSO4 and water, the first step produces an enol, vinyl alcohol, intermediate. The enol then undergoes ketoenol tautomerism to yield the final ketone product. Moving on to the next step. The intermediate must be a vinyl alcohol, enol, meaning it has an OH group directly attached to a carbon that is part of AC is equal to C double bond. This is the defining feature of the enol intermediate. And for the final step. Option A shows an allylic alcohol where OH is on a saturated carbon adjacent to a double bond, allyl alcohol type, CH2, OH next to C is equal to C. This is not an enol. It is an allylic alcohol. This is not the correct intermediate. Option B shows an enol structure where OH is on an internal sp2 carbon with a terminal is equal to CH2 group, i.e., a 1,1 desubstituted vinyl alcohol with OH on the substituted carbon. While this is an enol, the position of OH relative to the double bond and substituents does not match the expected Markovnikov product correctly for the given alkyne. Option C shows an enol structure similar to B, but with OH on a different carbon. Again an enol, but with substituent arrangement that does not represent the correct intermediate. Option D shows a vinyl alcohol, enol, where the OH is on the terminal is equal to CH carbon, i.e., O attached directly to the sp2 carbon of a terminal double bond, with the molecule having a branched chain. This represents the correct enol intermediate. The OH is on the vinylic carbon, sp2, making it a true enol that will tautomerize to a ketone. Therefore, the correct answer is option D.